This topic is about calculating measures of central tendency, such as mean, median, mode, measures of location, such as percentiles and deciles, and measures of spread, such as range, interquartile range, and interpercentile ranges. So let's go through measures of central location first. So it's a single value which describes the center of the data. So there are three types. So first type is mode or modal class, depending on what type of data is in front of you. So it's the value or class that occurs most often. Median, which is the middle value of an ordered set. And mean, which is denoted as x bar, which is equal to sum of x over n. So sum of all data values divided by the number of values, or in a frequency table, sum of f of x over sum of f. In a frequency table. And also sum of f of m over sum of f in a grouped frequency table. Where m is a midpoint of a class interval. So three different versions of formula for calculating the mean. M equals midpoint of class interval. Okay, so obviously depending on the data in front of us, either one of these three would be more appropriate to work out a measure of central location. So let's look at some examples and what we'd use in each one. So which average should you use? So by averages we mean these three things. So which average would you use for A? Now if you look at A, we have qualitative data in front of us. So that means mode is probably the most appropriate one. Mode, due to it being qualitative data. B, we've got 4, 5, 3, 7, 10, 200. We do have an extreme value there. So extreme values are sensitive and make calculating the mean. The mean is sensitive to extreme values. So median here is more appropriate. So median, mean is sensitive to extreme values. And we can see clearly that 100 is an extreme value there, so it's an outlier. C, we've got 56, 45, 67, 54, 49, 65, 52. Mode would not be appropriate here because everything comes up once, so obviously there's no mode. So you can have no mode, you could have more than one mode in examples. So here there's no mode, so that wouldn't be appropriate. There's no extreme value, so mean would be most appropriate here. Mean, because there's no outlier. And median, because if your order is just going to find the middle. So if there is no outlier, mean is more appropriate normally. D, there is no, you can calculate the mode here. There is no extreme value, so mean or even median. So I would say all are appropriate. But if I had to choose one, I'd probably choose mode. And the reason behind that is because the data is discrete and quite close together. So not many different values. So we've only got 0, 1, 2, 3. So it's very close together. Not many different values, so easier, most appropriate to work out the mode. Okay, next question. Joe collects 6 pieces of data, x1, x2, x3, x4, x5, and x6. He works out sum of x is equal to 256.2. Calculate the mean of this data. So A, mean of data is x bar, which is sum of x over n, which is 256.2. Divided by n is the number of data, which is 6, which is equal to 42.7. B, he collects another piece of data, it is 52. Write down the effect this piece of data will have on the mean. The mean would increase because 52 is bigger than the current mean of 42.7. C, given that the data is in size order and x3 is equal to 50, describe any change that may occur in the value of the median. So currently, before we add 52, we've got x1, x2, x3 is 50, x4, x5, and x6. And in this case, the median will be, the middle two numbers are 50 and x4, so the median will be 50 plus x4, divided by 2. So this is before adding 52. Now when we do add 52, there are 2 cases that we can have. So if 52 is greater than x4, then we get the case, then we have x1, x2, 50, x4, 50, x4, 50, somewhere, and then 52. We don't know what order, 52, x5, and x6 in some order. But the median would be x4. Oops, undo. Because x4 is in the middle. So here, we don't know, not in order. And then median will be equal to x4. So that's one case. If 52 is less than or equal to x4, then we have x1, x2, 50, 52, then x4, x5, and x6. Then the median will be, oops, undo. Because we have 7 numbers, the median will be 52. Then median will be equal to 52. So those are 2 different scenarios you get. So case 1 and case 2. Bob collects 6 pieces of data, x1, x2, x3, x4, x5, and x6. He works out the sum of x is equal to 432. Calculate the mean for this data. So the mean for this data is x bar is equal to sum of x over n, which is equal to 432 divided by 6, which is equal to 72. B. Bob decides x2 was incorrectly collected and replaces with a newly found value, so x2 changes from 38 to 35. Explain what effect this change will have on the mean. And because the number has decreased, then mean will decrease as well. So mean will decrease since one value has decreased, therefore total sum will also decrease. C. Given the data is in size order, describe any change that may occur in the value of the median. So at the moment, the median is x3 plus x4 divided by 2. So median is equal to x3 plus x4 over 2. So since x2 decreased, the ordered list does not change. Does not change for x3 onwards, basically. Therefore, median will still be x3 plus x4 divided by 2. Therefore, median is unchanged. Okay, so next thing we want to go to is quartiles for discrete data. So the quartiles, we have lots of definitions that I need to go through. So lower quartile which is denoted as Q1, is a quarter of the way through the data set. Then we have median, which is denoted Q2, which is half of the way through the data set. Upper quartile which is Q3, which is 3/4 of the way through the data set. Now we can have the 13th percentile, for example, which is denoted as P13, is 13 over 100 of the way through the data set. And we can also have, for example, the second decile, which is D2, which would be 2 out of 10 of the way through the data set. So obviously you can also work out the fifth decile, the 72nd percentile, so on. It still means the same thing. So you just change n according to. So if we call this 13n, then it'd be n out of 100. If it's nth decile, then it's n out of 10 of the way through the data set. Okay, so rules. So rules for discrete data. So let's go through the rules. So just important that it's only for discrete data this is. So if I want to work out Q1, then it's the quarter nth value. And you can either get a whole number. When you do the quarter nth value, this number can either be whole number or it can be a decimal number. Now, if it's a whole number, the lower quartile is halfway between the quarter nth value and quarter n plus 1th value. If it's a decimal number, you round up and pick the quarter round up and pick that number. So pick that value. So round up and pick that value. So it's best demonstrated using an example. The same thing works with, by the way, with Q2 and Q3. So if I want to work out Q2 is a half nth value. Now if this is a whole number and if it's a decimal number, now if it's a whole number, it's halfway between half nth plus half n plus 1th value. If it's a decimal number, you round up and pick that value. And same thing with Q3, which is 3/4 nth value. If it's a whole number, it's halfway between 3/4 nth and 3/4 n plus 1th value. If it's a decimal, then you round up and pick that value. So let's go through. So these are the rules. I don't know if I should highlight it in a different color. Okay, so let's apply this to some examples. So from large data set, the daily maximum gust in knots during the first 20 days of June 2015 is recorded in Herne. The data is shown below. Find the median and the quartiles for this data. So I can see straight away n is equal to 20. So if I want to work out Q1, I have to do a quarter of 20, which is equal to, I get 5. Now because it's a whole number, 5. So 5 is whole number. Therefore, I'm taking the 5th plus the 6th value and divide by 2. So 5th, 1, 2, 3, 4, 5, which is 18, plus 18 divide by 2, which is 18. Therefore, Q1 is equal to 18. What I'm going to do is I'm not going to write that. Okay, so that one was for Q1. Okay, so next one I need to do is median, which is half of 20. Half of 20 is equal to 10. 10 is a whole number. Therefore, I'm going to take the 10th value plus the next value, which is 11th, divide by 2, which is equal to 22 plus 23, divide by 2, which is 22.5. Therefore, Q2 is equal to 22.5. Okay, and the last one I need to do is 3/4 of 20, which is 15, which is a whole number. Therefore, I need to take 15th plus the next number, which is 16th, and then divide by 2, which is 25 plus 26, divide by 2, which is 25.5. Therefore, Q3 is equal to 25.5. Okay, quartiles for continuous data using linear interpolation. So you have to use this process called linear interpolation when you're working out Q1, Q2, and Q3 for, continuous data. Now, for Q1, there is no rounding up or down. There's no rule for when it's a whole number and it's a decimal number. So what you do is you just take the 1/4 nth data value. Okay, so there's no rounding, there's no separate rules for each situation that arises. Okay, for Q2 will be half nth data value, and for Q3 is equal to the 3/4 nth data value, and so on. So it's much more simpler when it's continuous data. So linear interpolation relies on the fact that if we know, for example, I'm just going to show you a quick example. If Q1 lies between two class intervals, and Q1 is obviously the quarter nth value, which lies between two frequency, let's just call it frequency 1 and frequency 2, and this lies between two class intervals, class 1 and class 2, then what that means is that the spaces between these will be proportional. So if this is A and B, and this is C and D, then we know A over B must be equal to C over D. And that's what we use to work out. This is the process of this is what we use for linear interpolation to figure out what Q1 would be, Q2 would be, and Q3 would be. So it's best demonstrated using an example. So let's go through that. So use linear interpolation to find an estimate for the median of the data value. Now it's an estimate because of the fact that we're using proportionality to work it out. Okay, and obviously we don't know the exact values because it's a grouped frequency table. The table shows the daily mean temperature at Heathrow in October 1987 from the large data set, and find the median. Okay, so first thing I would do is to work out total frequency, 3 plus 7 plus 9 plus 7 plus 3 plus 2, which is equal to 31. Okay, I'm trying to work out the median, so Q2 is equal to half of 31, which is equal to 15.5th value. Now, if I that means if I draw a diagram, I know Q2 is the 15.5th value. If I do a cumulative frequency, then this is 3. 3 add 7 is 10. 10 add 9 is 19, 26, 29, and 31. And that means that because I'm looking for the 15.5th value, then it would be in this class interval. Because here it's up to 10, and the previous one's up to 10, here it gets to 19. So somewhere in the 10 to 12 class interval. So that means Q1 lies, the lower bound of this is 10, the upper bound of this class interval is 12. So between 10 and 12, and the frequency goes from 10 at the end of 10 to 19. Okay, so 10 to 19. Okay, so that means because of proportionality, A over B must be equal to C over D. So A is, therefore, A over B is equal to C over D, which implies A is Q2 minus 10 over B, which is 12 take away 10. The space between B is 2, must be equal to 15.5 over take away 10, which is equal to 5.5 over 19 take away 10, which is 9. So if I rearrange this, I get Q2 is equal to 5.5 over 9 times by 2, add 10, which means Q2 is equal to 11.2222 recurring. So to 2 decimal places, Q2 is equal to 11.22. Okay, so let's estimate the mean for the following sets of data. So doing the same thing, so just getting used to linear interpolation. So question 1, so 6 plus 10 plus 18 plus 13 plus 2 is equal to 49. So working out the mean, so Q2 is equal to half of 49, which is equal to 24.5th value. So that means for my linear interpolation, I've got Q2, which is 24.5th value. So if I do a cumulative frequency, 6, 16, 16 plus 18 is 34. Okay, so that means it's in this class interval because that's when we've gone past 24.5. Okay, so it lies between 40, Q2 lies between 40 and 50, so upper bound and lower bound are 40 and 50, and it goes from 16 to, the frequency goes from 16 to 34, and 24.5 lies between 16 and 34. So that means A over B must be equal to C over D, which means Q2 minus 40 over B, which is 50 take away 40, which is 10, must be equal to 24.5 minus 16, which is 8.5 over 34 take away 16, which is 18. Now if I rearrange it, Q2 will be equal to 8.5 over 18 times by 10 plus 40, which is equal to 44.72222. If I round it, I get 44.72. So that's one done. If I go here for 2, then I've got 2 plus 25 plus 30 plus 13, which gives me a value of 70. So Q2 is half of 70, which is the 35th value. So Q2 is equal to 35. Okay, so if I work out the cumulative frequency, I've got 2, 27, and then 67. So I know it lies between 34 and 36. Now be very careful here. There's a gap here, so that means the lower bound of this class interval is 33.5, and the upper bound of this class interval is 36.5. So there is no overlap. So make sure you write not 34 and 36, but 33.5 and 36.5. So always look at the gaps if are there gaps in between the class intervals. Okay, and it goes from 27 to, sorry, I made a mistake there. 27 plus 30 is 57. Okay, so remember A over B is equal to C over D, which implies Q2 minus 33.5 over 36.5 take away 33.5 is 3, is equal to 35 take away 27, which is equal to 8 over 30, which implies Q2 is equal to 8 over 30 times by 3 plus 33.5, which implies Q2 is equal to, gives an exact value of 34.3. Okay, next question. The length of time to the nearest minute spent on the internet each evening by a group of students is shown in the table. Find an estimate for the upper quartile. Okay, upper quartile is Q3. So first thing I need to do is work out the total. So 2 plus 25 plus 30 plus 13 gives me a value of 70. So Q3 is equal to 3/4 of 70, which is equal to 52.5 value, which means if I draw my diagram out, I've got Q3, which is 52.5. If I do a cumulative frequency, I've got 2, 27, 57, and 70. So if I'm looking for 52.5, so it must be in this class interval. Again, the lower bound is 33.5 and the upper bound of the class interval is 36.5. So it goes from 33.5 to 36. So Q2 lies between 33.5 36.5, and the frequency lies between is 27 and 57. A over B must be equal to C over D, which implies Q3 minus 33.5 over 36.5 take away 33.5, which is 3. 52.5 minus 27 is 25.5 over 57 take away 27, which is 30, which implies Q3 is equal to 25.5 over 30 times by 3 plus 33.5, which is equal to 36.05. Find the estimate for the 10th percentile for part B. So 10th percentile is P10, which is 10 out of 100 of 70, which is equal to the 7th value. So if I have my P10 is the 7th value, which will, if I just use a different color, the 7th value is going to lie in this class interval. So again, if I'm looking at 7, it lies between the frequency of 2 and 27. And the lower bound of that class interval is 31.5 and the upper bound is 33.5. So A over B is equal to C over D, which implies P10 minus 31.5 over 2 must be equal to 5 over 27 take away 2 is 25, which means P10 must be equal to 5 over 25 times by 2 plus 31.5, which gives me an answer of 31.9. A roadside assistant firm kept a record over a week of the amount of time in minutes people were kept waiting for assistance. The times are shown below. Find an estimate for the mean wait time. So A will be equal to X bar. Because it's grouped frequency table, it's sum of f of m over sum of f. So it will be, find the midpoint, so f times m, so this is f, and m is the midpoint of each class interval. So it will be 25 times 6 plus 35 times 10 plus 45 times 18 plus 55 times 13 plus 65 times 2, all over the total frequency, which is 6 plus 10 plus 18 plus 13 plus 2. Now, when I do that in my calculator, I get 43.97959, blah, blah, blah. Therefore, if I round it, is equal to 43.98. Okay, part B. It says calculate the 65th percentile. So first thing I would do is work out the total frequency, which is equal to 49. So if I'm working out P65, it's 49 over 100. Sorry, 65 over 100. So 65 over 100 times 49, which gives me the 31.85th value. So remember, no rounding because it's continuous data, which means if I have P65, which is 31.85, if I do a cumulative frequency, I get 6, 16, 16 plus 18 is 34. So I know straight away it lies on this interval. Okay, upper bound is 40 and 50, so it lies between 40 and 50, going from 16, the frequency going from 16 to 34. So this is A, B, C, and D. So A over B is equal to C over D, which implies P65 take away 40 over 50 take away 40, which is 10, must be equal to 31.85 take away 16, which is 15.85 over 34 take away 16, which is 18. Which means P65 is equal to 15.85 divided by 18 times by 10 plus 40, which gives me a value of 48.80555 recurring, which is equal to 48.81. Okay, next question. The firm writes the following statement for an advertisement. Only 10% of our customers have to wait longer than 56 minutes. But calculate a suitable percentile comment on the validity of this claim. So if it's only 10% have to wait longer, what we're trying to calculate is P90. Because if it's 10% wait longer, then it's 90% wait less than, yeah? So P90 is what we're trying to calculate. So part C is calculate P90. So P90 is equal to 90 over 100 times N, which is 49, which is the 44.1th value. So that means we've got P90 somewhere, which is the 44.1th value. So if I continue adding doing the cumulative frequency, 34 at 13 is 47, and you get 49. So straight away we know it's for part C, it's in this interval. So that's going to be between 50 and 60, going from 34, the frequency going from 34 to 47. So A over B must be equal to C over D, which implies P90 take away 50 over 60 take away 50, which is 10, must be equal to 44.1 take away 34, which is 10.1 over 47 take away 34, which is 13. So if I rearrange it, I get P90 is equal to 10.1 divided by 13 times by 10 plus 50, which gives me 57.76923, which is equal to 57.77 minutes. Okay, now therefore, that means 90% of customers wait less than 57.77 minutes, which implies 10% of customers wait more than 57.77 minutes. Now, the claim was it's longer than 56 minutes, but it's actually more than 57.7 minutes. Therefore, claim is not valid. Therefore, claim is not valid because it's not 56.